It's kind of strange to think, isn't it? We actually know more in some ways about the moon and Mars than our own deep oceans.
It really is surprising, but India is taking a pretty big step to change that with the Samudrayaan mission.
Exactly. Samudrayaan. So tell us a bit about what this mission is all about.
Well, fundamentally, it's about exploration. The deep sea is largely unknown territory, right? The National Institute of Ocean Technology, NIOT, in Chennai, is heading this up. They want to explore, understand the environment, and yes, also look for potential resources.
And the key piece of tech here is Matsya 6000. That's the submersible.
That's right. Matsya 6000, it's a manned submersible designed to take 3 people down to depths exceeding 5,000 meters. Pretty impressive.
5,000 meters. Wow. And what's special about its construction? I heard something about ISRO.
Yes, that's a fascinating detail. The core, the personnel sphere where the crew sits, is this 2.1-meter sphere made of titanium alloy, super strong to withstand the pressure. And yes, it was developed with ISRO.
India Space Agency helping build a deep-sea vehicle. That's quite something.
It really highlights the advanced engineering involved, doesn't it? You need that kind of expertise for these extreme environments, whether it's space or the deep ocean.
So, okay, what else does a vehicle like Matsya 6000 need to actually, work down there?
Well, there's a whole suite of systems. You need buoyancy control, basically managing how it goes up and down. Power systems, obviously. Thrusters or propellers for maneuvering.
Right.
Then you've got robotic arms, they call them manipulators, to interact with things. Navigation is crucial. Communication, too. Energy storage, and critically, emergency life support.
Makes sense. And the name Matsya.
Ah, yes, Matsya. It means fish in Sanskrit, and it's also the name of Lord Vishnu's first avatar who took the form of a fish, so quite symbolic for deep-sea exploration.
Fitting. And how long can it operate?
It's designed for about 12 hours of continuous operation at depth, but crucially, it has a 96-hour emergency endurance, safety first.
Absolutely. Okay, so before they sent it down thousands of meters, they did these wet tests. What exactly were those for?
Right, the wet tests. These were absolutely vital. Think of it like a systems check, but in the water. They needed to validate everything, all the individual components, how they work together, the whole assembly.
Because it's complex, I imagine.
Incredibly complex. You're talking over 1,000 parts, hundreds of new technologies, all needing to function flawlessly under pressure. So these initial harbor tests were essential.
And these happened in Chennai.
Yes, at an L&T harbor there. A controlled environment to start with. They did 10 dives in total.
10 dives. Some unmanned, some manned.
That's correct. 6 unmanned first.
Okay, what did they check on the unmanned runs?
Those were about basic functionality at shallow harbor depths.
Uh-huh.
Things like insulation, making sure no water gets into the electrical systems. Very important. Flotation and stability checks. Does it float correctly? Is it stable? Inclination tests, checking weight balance. And then a basic submergence test, just down to about 1.5 meters, to make sure the ballast tanks work for diving and surfacing.
And they even simulated the control room setup.
They did. During the unmanned tests, Matsya was connected by an Ethernet cable back to a container set up like a mission control. It mimics how they'll operate from a ship later on, so it was good practice.
Smart. Then came the manned dives. Must have been a big moment.
A very big moment. 3 engineers went inside, led by J.P. Singh. He's actually a former Navy submariner, so brings invaluable experience as the lead pilot.
Oh, wow. So they're testing the human element now.
Exactly. Life support systems were key here. Oxygen levels, CO2 removal scrubbing, they call it moisture control, communications inside the sphere, power checks, cameras, sensors, everything needed to keep the crew safe and comfortable.
And did they test movement?
Yes, they started testing the maneuvering propellers initially with some support from a crane, just to be safe. And they switched communications too.
Switch from what?
From the wired Ethernet used in the unmanned tests to acoustic communication. That's the standard way ships and subs talk underwater. Like sonar, but for data and voice.
Okay, got it. And the Ministry of Earth Sciences had specific goals for these tests.
Yes, they specified checking the robustness of power and control, confirming the flotation and stability again, verifying the human support and safety systems worked as designed, and testing limited maneuverability, just basic forward and backward movement for now.
Sounds like a thorough shakedown cruise. So with these tests done, what's the bigger picture? What is Samudrayaan ultimately aiming for in the deep ocean?
The main goal now is to explore India's exclusive economic zones, the EEZs, and the continental shelf. These are vast areas of the ocean where India has rights to explore and use marine resources.
And this ties into the blue economy idea we hear about.
Absolutely. It's a key part of India's blue economy strategy. The deep sea is believed to hold significant resources. For anyone listening, particularly maybe UPSC aspirants, understanding EEZs and their connection to resource management is pretty important.
Right. What kind of resources are we talking about?
Well, the focus is on valuable minerals, potential energy sources, and also unique marine life biodiversity.
Specific minerals.
Yes, Dr. S. Ramesh, the scientist in charge, mentioned polymetallic nodules specifically. These are like lumps found on the seabed, rich in manganese, iron, nickel, copper, cobalt. Really valuable metals.
Interesting.
They're also looking for gas hydrates, sort of like ice that contains methane, a potential energy source, and cobalt-rich crusts on underwater mountains. Discovering and potentially utilizing these could be economically significant for India.
So India is really pushing the boundaries here, not just in space, but now deep underwater too.
Exactly. It's about aiming longer and deeper, as they say. Samudrayaan positions India alongside other nations involved in deep-sea exploration. It reflects a global trend, really, recognizing the importance of understanding and sustainably managing this last great frontier on Earth.
Again, for our listeners, especially those preparing for exams like UPSC, this really touches on science and tech, resource management, India's strategic initiatives. It covers a lot of ground.
It certainly does. It's a major national project with wide-ranging implications.
Okay, so to quickly recap, India's Samudrayaan mission, with its submersible Matsya 6000, has cleared its initial crucial wet tests. This is a big step towards exploring our deep oceans, potentially unlocking resources, and boosting India's scientific and economic standing. Definitely something to keep an eye on.
And perhaps this leaves you, the listener, with something to think about. As we get better at reaching these incredibly deep, previously untouched parts of our planet, what are the ethical questions? How do we balance the potential benefits of resource extraction with protecting these unique, fragile environments? How do we ensure exploration is responsible?
That's a really critical question for the future, isn't it? Something we all need to consider. Well, we hope this deep dive into Samudrayaan was useful for you. If you found it insightful, please do like, subscribe, and maybe drop a comment below with your thoughts or any questions you might have.
We'd love to hear from you.
And just a reminder, our discussion today was based on reporting from India Today. Thanks for tuning in.